So the second topic in module 2 is Gram-Schmidt's orthogonalization procedure, okay? And the university question asked is explain the Gram-Schmidt's orthogonalization procedure. It is asked for 8 marks from July 2018. So what is the main use of this procedure is that it is useful to find out the values of your orthonormal basis function. So what was your orthonormal basis function? We have seen in previous video phi 1 of t, phi 2 of t, right, etc. up till phi n of t. So in general, the first basis function, in short, let me explain first, okay. The first basis function, that is phi 1 of t, is written directly, okay, right, directly from your signal S1 of t divided by your energy of the signal, that is root of E1. So this is your formula for finding out the first basis function. Phi 1 of t is equal to S1 of t divided by root of E1, whereas 1 of t is your signal, first signal, and your energy of that corresponding signal S1 of t, that is your E1, okay. Now, if you want to find out the other orthonormal basis function, that is phi 2 of t, phi 3 of t, etc. up till phi n of t, you have to introduce an intermediate signal that is called as gi of t. Gi of t is equal to si of t minus summation j is equal to 1 to I minus 1 into sij into phi j of t. So you know that in geometrical representation you have already derived what is meant by Sij. Sij, the coefficient Sij is equal to 0 to t Si of t into phi j of t into dt. Okay, so now by using this intermediate function, you are going to find out the value for your phi 2 of t, phi 3 of t, phi n of t, etc. Okay, now in general, I can write that phi I of t is equal to gi of t divided by root of energy of that particular signal. In the case of first basis function, this gi of t will be replaced by the signal itself, S1 of t itself. Now, for the second basis function, instead of Si of t, you are going to replace it by gi of t, in which the gi of t is given by your Si of t minus summation j is equal to 1 to I minus 1 Sij into phi j of t. Similarly, phi 3 of t will be equal to g3 of t divided by root of e g3 of t, etc. So now you are going to derive these values, phi 1 of t, phi 2 of t, phi 3 of t. So these are the four main equations what you are going to use. Phi 1 of t, then gi of t, sij, and e. What is your energy of your signal? E gi of t is equal to 0 to t gi the whole square. That is, energy is equal to 0 to t of the signal s square of t into dt, right? The same signal, same equation is replaced by gi square of t instead of s square of t. Okay. So moving on to your first step. So before that, let me tell what Gram-Schmidt's orthogonalization procedure. It is a tool to obtain the orthonormal basis functions phi I of t. Now let us consider m energy signal. What are the energy signal? S1 of t, S2 of t, etc. up till Sm of t. The first basis function is given by, as I have mentioned before, phi 1 of t is equal to S1 of t divided by root of E1, where E1 is your energy of the signal S1 of t, where E1 will be equal to, what will be your value? 0 to t S1 square of t into dt. Okay. So from this, can we find out the value for S1 of t? If you cross multiply these two, right? S1 of t is equal to root of E1 into phi 1 of t. Now in general, you know that what is your Si of t? Si of t is equal to summation j is equal to 1 to n Sij into phi j of t. This is from the geometrical representation, right? So if in this case, now we have to find the first case, right? So in the first case, what will you get? If I is equal to 1, what will you get? S1 of t is equal to summation j is equal to 1 to n. In this case, phi, it is 1 of t, j is equal to 1, right? So here you have j is equal to 1, S1j into phi j of t. So here in this case, it is written in the next step, okay? J is equal to 1. So now I can reconfigure it into S1 of t is equal to, here you have only the one value, right? J is equal to 1. So instead of j, you are substituting the value as 1. So S11 into phi 1 of t. Okay. So I have written this equation here. S1 of t is equal to S11 of t into phi 1 of t. So I can write that S11 is equal to root of E1. If I compare these two equations, where the coefficient, this coefficient is equal to root of E1. And since it is an orthonormal basis function, you will have phi 1 is equal to it's having a unit energy, right? So now you have found out phi 1 of t. Now what is your next step? Step 2, you are going to find out the next orthonormal basis function, that is phi 2 of t. So as I have mentioned before, in order to find out the second basis function, or the second to the next greatest basis function, you have to introduce a new term that is called as intermediate function. Intermediate function is given by the formula gi of t is equal to si of t minus summation j is equal to 1 to I minus 1 sij into phi j of t. What will be the value for I? I is equal to message signal, right? 1, 2, 3, etc. up till m. So now you are going to find when I is equal to 2. That is, your task is to find your second orthonormal basis function, right? Second basis function phi 2 of t. So now I is equal to 2. When I is equal to 2, what will be your value? Replace I by 2. What will you get? G2 of t is equal to S2 of t minus S21 into phi 1 of t. Why did you get here 2, 1? J is equal to 1 to I minus 1. Now I is equal to 2. 2 minus 1 is again 1. So you have only one value for J. J is equal to 1. That's why you have replaced J by 1. S21 into phi 1 of t. Take that as equation 2. Now what will be your second basis function? G2 of t divided by root of G2 of t divided by root of energy of that particular signal. G2 Eg2 of t, right? What is Eg2 of t? You know that it is 0 to t g2 square of t into dt. Okay. Now you are going to solve this formula. Now you are going to find out the value for energy. So let us take 0 to t g2 2 square of t into dt. So I have solved it here. Okay. 0 to t g2 square of dt is equal to, instead of g2 of t, you are going to substitute the formula. What is the formula? S2 of t minus S21 into phi 1 of t the whole square into dt. Now it is in the form a minus b the whole square, right? So a square plus b square minus 2ab. You are going to substitute the formula. So 0 to t a square is equal to S2 square of t. Then you have plus b square, right? S2 1 square into phi 1 square of t minus 2 into S2 of t into S2 1 into phi 1 of t into dt. Now cross multiply it inside. Individually you are taking 0 to t S2 square of t into dt plus, what is the constant here? S21 square I have taken it as constant, 0 to t phi 1 square of t into dt. Since it's an orthonormal base function, you can take this term as equal to 1. Minus 2 into S21 into 0 to t S2 of t into phi 1 of t into dt. What is this S2 of t into phi 1 of t into dt? What will be your value? That is equal to your coefficient S21, right? By applying the formula, what was your formula? The formula Sij is equal to 0 to t Si of t into phi j of t into dt. Okay. So if I substitute it as S21, I is equal to 2, j is equal to 1, you will be getting S2 of t into phi j is equal to 1, right? Phi 1 of t into dt. So I can replace this by S21. That's what written in the next step. So you will be getting here 0 to t S2 square of t into dt. What will be this? It is your energy of the signal S2, right? So E2, I can write it as E2. E2 plus S21 square minus 2 into, because this is equal to 1. So 2 into S21, and this I have replaced by S21. So what will be a value? E2 plus S21 square minus 2 into, this is also square, right? S21 square. Minus 2 S21 square plus S21 square, you will be getting S21 square. That now you can replace your 0 to t g2 square of t into dt will be equal to E2 minus S21 square. So this I have substituted in here. Okay. So instead of root of 0 to t g2 square of t into dt, I have replaced this value by E2 minus S21 square. So root of E2 minus S21 square, and g2 of t I have substituted the value S2 of t minus S21 into phi 1 of t. So this will be your second basis function phi 2 of t. So what will be your E2? E2 will be your energy of the signal S2 of t. So now you have found out phi 2 of t. Similarly, can you find out the value for phi 3 of t? What will be your value? G3 of t divided by root of E G3 of t, right? So in general, it can be defined as phi 1 of t, you can write one more step. Phi 1 of t is equal to S1 of t divided by root of E1. And for the second basis function, you are going for your intermediate term. Gi of t is equal to Si of t minus summation j is equal to 1 to I minus 1 Sij into phi j of t, where the coefficient Sij is equal to 0 to t Si of t into phi j of t into dt, which we have seen in your geometric representation. For I is equal to 1, the function Gi of t reduces to Si of t. Okay. Now, given, and these are the three important formulas what you are going to use. Therefore, phi I of t is equal to, what will be the value? Gi of t divided by root of Egi of t. So, this is Egi of t is replaced by 0 to t Gi square of t into dt. So, these are the three formulas which you are going to use in your Gram-Schmidt's orthogonalization procedure, and in the next video we will see the different problems related to it.